All right, I'm going to start with practice A. The first bunch tells you to evaluate. What does 5 to the third mean? It means 5 times 5 times 5, which is 125. What does a negative exponent mean? This means 1 over 2 to the first, besides that exponent still exists. This is the exponent. The negative says put it in the denominator or change its place in the fraction, because really that is in the numerator. So this is just 1 over 2. What's going on here? It's power of a product. See, I don't even know the rules. Product of a power. Product of two powers. Same base, -3 times -3. Here it's being multiplied by itself 4 times. Here's one more. I put that one in there. So that is -3 to the 5th. The parentheses are essential because if this was an even exponent, what would happen when you multiply a number by itself an even number of times? So this exponent belongs to that negative as well. So the parentheses are important. If I had -3 to the 5th, that would mean negative, and then 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. See, this 5 only belongs to the 3, not the negative. This 5 belongs both to the negative and the 3. How about 7 to the 0 raised to the 5th? The rule says multiply the exponents when I raise a power to a power, and anything times 0 is 0. And of course, we remember that anything to the 0 is 1. And then what happens here? Well, think about this again. How many? I have 7 3s on the top. I have 4 3s on the bottom. 3 times 3 times 3. No, I don't expect you to do this. 1, 2, 3, 4, 5, 6, 7. And then there's 4 on the bottom. And what happens? They cancel, but what does canceling really mean? 3 over 3 is 1. 3 over 3 is 1. So cancel, remember, means 1. And what am I left with? 3 to the third. Why is that? Because 3, I subtract the exponents. 7 minus 4 is 3. What happens here, though? So there's 2 ways to think about this. I can't give you just one thing. I could use the rule and subtract, and I would have 8 to the 2 minus 3, which is 8 to the -1, which we remind ourselves is 1 over 8. But again, if you think about this idea of having 2 8s on the top and 3 8s on the bottom, 2 of them are going to cancel, and you're going to be left with 1 on the bottom. That's kind of how I like to think about it, and you'll see that later when we get into more complex examples. So that's up to you. You can use the rule, but then you have to remember the negative exponent. Here I can see that 2 of my 8s are going to cancel. I'm going to have an extra 1 on the bottom. Scientific notation, remember, has a particular form. This number out front has to be greater than or equal to 1, but less than 10. I can't go over 10. So what do? This decimal point's way over here, so I really want it to be right there, because 5.26 is a number greater than or equal to 1, but less than 10. It can't be 52.6. It can't be 0.526. So what have I just done? I have just moved the decimal point 1, 2, 3, 4, 5. I've just moved it 5 places to the right to get it there. So to compensate for that, I have to tell the person reading this that really that decimal point belongs 5 places to the left. So however you want to think about that. Now in this case, again, what's my C have to be? It's going to have to be 5.983. And what do I need to tell the reader? Well, that decimal place really belongs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Really belongs 12 places to the right. And then again, what's my number going to be here? It can't be 0.7, so it has to be a number between 1 and 10. Could be 1. So I'm going to have 7. And we don't really put a 0.0 because technically there isn't a 0 there. If you think about science, this measurement was as precise as it got. There wasn't another place after that. So I need to move 1, 2, 3, 4, 5, 6, 7. So that's 10 to the negative 7. I got to tell the reader to move it back 7 places. Scientific notation. How to take a really, really, really small number or a really, really, really big number, that's what scientists use, and write it so that it's more convenient. Not only then is it more convenient, but then I can multiply and divide more easily. So here's a number in scientific notation. Here's a number in scientific notation. Remember, if I have 3 times 6 times 5 times 4, I can do 3 times 4 times 6 times 5 if I want to. So this is just this times this times this times this. So to make things convenient, I'm going to do 5.7 times 6.2. And then I'm going to do times 10 to the negative 6 times 10 to the 8th. And I'm going to do that on my calculator. 5.7 times 6.2, and I get 35.34 times 10, and I add exponents. Times 10 to the 2. Look how beautiful that is. Negative 6 plus 8 is 2. Now I can't leave it like this. This is not greater than 1 and less than 10. So I have to move my decimal point 1 place to the left. So to compensate for that, I'm going to make this 1 place larger. I just made this 1 place smaller, so I have to make this 1 place larger. What about the rules here? Remember, the squared belongs to the 4.3, and the squared belongs to the 10. So I'm going to square 4.3, and I get 18.49. And 2 times 2 is 4, 10 to the 4th. Again, I can't leave it like that. So 1.849. Again, I just made this smaller, so I have to compensate by telling the reader to move 1 more decimal point to the right. Just like up here, when I could conveniently multiply, here I'm going to conveniently divide. So I'm going to have 3.6 divided by 4.8, and that's going to be 10 to the negative 5th over 10 to the negative 7. And 3.6 divided by 4.8 is 0.75. You can actually sort of figure that out because each of these divided by 8 is, no, that's not right. Yeah, 4 over 6, 3 over 4. Anyway, so 0.75. Now again, depending on how you do this, if you say negative 5 minus a negative 7, you're going to get 10 squared, negative 5 plus 7. Another way to think about it is, look, if I switch this, this really belongs in the numerator. I get a 10 to the 7th. This really belongs in the denominator because it's got a negative exponent. I have a 10 to the 5th. So again, either way, I get a 10 squared. Now again, I can't keep the 0.7. I got to move this guy 1 to the left. So I just made this number bigger. I got to make my 10s smaller by 1. Move my decimal point to the right 1. To compensate for that, I got to move my 10s places to the left 1. And just a quick recap of some of the more fundamental problems we started with, all involved in numbers. So how do I apply these rules with variables? Well, again, we still add x squared. Here, each the exponent belongs to each part of this product, so 5 squared is 25. Again, I subtract, and here's, again, Viv might give you a little different method. 2 minus 6 is negative 4, which means 1 over m to the 4th. But the other way to look at that is if I have 2 m's on the top and 6 m's on the bottom, I'm going to be left with 4 extra once 2 of those m's, once 2 of those m's cancel, there's going to be 4 m's left on the bottom. But if you use the rule of subtraction, you get m to the negative 4th, which we have to remember is 1 over m to the 4th. Now what does this mean? Well, negative means to flip it. And then it's still squared. So this is 4 squared over n squared, which you could write as 16 over n squared. But when I have a fraction raised to a negative exponent, I automatically just flip it. That's really what a negative exponent means. All right, I'm going to stop this video here. They're much easier to load if they're shorter. And then I just have a few more more challenging ones to show you. So if you feel like this is enough for you, work on practice A and do a lot. Although I think I did a lot of the evens. I would encourage you to try some from practice B and C.